Section 5.4, Day 1 Factoring Notes. Factoring is very important to what we're going to do for the remainder of the year, so it's important to listen carefully and take good notes. Now the first one is just something easy. It says list all the factors of 32. So the factors of 32 I know are 1 and 32, 2 and 16, and 4 and 8. Because when you take 1 times 32, you get 32, 2 times 16 is 32, and 4 times 8 is 32. Now, if you're somebody that has difficulties with your factors, something that you could easily do is go to your calculator, and in your y equals, whatever the number is that you're trying to find the factors of, type that in and divide it by x. And then if you go to your table, you will see the factors. So 1 and 32, start with 1 always, 2 and 16, 4 and 8, and if you keep scrolling down, when you get back to something that you've seen before, so we had 4 and 8 before, and now we have 8 and 4 right here, that's when you know you can stop, because 4 times 8 is the same thing as 8 times 4. And so those are all the factors of 32. Now, that's just factoring numbers. Now we're going to talk about factoring polynomials. When you're factoring polynomial equations, it's a little bit different than just looking at the factors. You have a couple of different things you have to do. The number one thing is to make sure that you always factor out a greatest common factor first. This step is very important. That should always be step number one. After you do that, and of course this is after you've already combined all like terms and everything and it's in standard form, then you look to see how many terms do you have. Do you have 2 terms, a binomial, or do you have 3 terms, a trinomial? So if you have 2 terms, a binomial, then you would look for specific patterns that we have. Now, we're not going to really talk about these patterns today, but I'm just going to tell you what they are for right now. The patterns are difference of cubes, and then we have one of them should say the difference of cubes, one should say the sum of cubes, and this should say the difference of squares. Sorry, I don't know why that got messed up there. So difference of cubes, the difference of squares, and the sum of cubes are the 3 different patterns. But like I said, we're not going to really talk about that. So we're going to focus more on the other half of this. Now, if it's 3 terms, then we can do something specific. So 3 terms is a trinomial, and that means we're going to factor it. So there's 2 different factorings. If the leading coefficient is 1, then you're going to find factors of the last term that add up to the middle term. If the leading coefficient is not 1, then we're going to use this specific method called slide and divide to factor. Now, I'm not going to talk about that right now, but I will get back to it once we get to some of those examples. So I'm going to skip over this part right here and get to some examples. So we want to simplify these, or actually not simplify, but we want to factor these. So we're going to factor. Now, if we want to factor it, if it has 2 terms, we're just going to always look for a greatest common factor first. So your greatest common factor is something that goes into each of the terms. If we look at this right here, we can split this up into a times a times a times b, and this one would be minus a times b times b. So if you want to look for terms that are common in both, we'll notice that we have an a in both of them, and we also have a b in both of them. So 1a and 1b. That means my greatest common factor is going to be a times b. Now, if we want to factor this out, that really means that you're dividing it out of your equation. So we're taking a cubed b, and we're dividing out a times b, and then minus ab squared, and we're dividing out a times b. So when we do this, the way that you would write that, if you're dividing it out, that means you're really putting it in front. And then a cubed over a gives me a squared, because we've learned our properties of exponents, and b over b would be gone, so that's just 1, minus a over a is 1, b squared over b would be minus b. So this right here would be my factored form for this equation. And since we're not going to learn about the patterns just yet, we would know that we would stop there. Now, it's easy to check your work because we can check by distributing. So if I were to check, which I'm going to write down here because otherwise I'm going to run out of room, I would distribute back in. So AB times a squared and then times b. So ab times a squared gives me a cubed b minus AB minus B, AB times negative B, I should say, would be negative AB squared. This, notice, is the same as what we started out with, so I know I did my problem factoring correctly. So let's go to the next one. 5x squared y minus 15x y cubed z. Now, again, we always want to look for our greatest common factor first. So you want to look to see what goes into both of them. So one way you can do this, if it helps, is what we did for the first one and write out all the terms. So 5 doesn't factor at all, so 5 times x times y. 15, I know that I can factor into 5 times 3. So you always want to do the prime factorization of the number, so 5 times 3 times x, y times z, and so you would look at what goes in both of them. So I noticed that 5 is common in both. Also, we have an x in both and a y in both. So 5xy is my greatest common factor. When you get good at this, you don't really need to write all of that out. So that means that I'm going to divide each term by 5xy. So when I do that, that means 5xy goes in front, and then 5 over 5 would be 1, so x squared over x gives me x, and then y over y is 1, so that's gone, minus 15 divided by 5 is 3, and then x over x is 1, y cubed over y gives me y squared, and then z doesn't have anything, so it just stays there. And this would be my correct factored form. And of course, if I wanted to check this, I would take my terms and multiply it back through, and I would see that I would end up with what I originally started with. So why don't you pause the video and see if you can do number 3 on your own. So first things first, find your greatest common factor. So what goes into all of them? Now you should have noticed for this one that the common number we have is 10. And notice that we have m and n in all of our terms that we have here. So the highest m that goes into all of them would be just 1m. And the highest n that would go into all of your equations would be 1. So 10mn would be your greatest common factor. So that means we're going to divide each term by 10mn. And so when we do that, 10mn goes on the outside because we're factoring it out or dividing it out. So factoring is kind of like dividing. And you end up with 50 divided by 10 is 5. M squared over m just gives me 1m. N to the fourth over n to the first. Subtract your exponents and you get n to the third. Minus, this would be your 10m and your m's cancel out. So you end up with n to the third over n, which is n squared. And then plus 120 divided by 10 is 12. And then we have mn when you simplify your variables there, minus, and then right here, this all cancels out, but you can't put 0 or leave it out. You still need that placeholder of 1. And the reason I know that is because if I were to distribute and multiply back through, I still need that term there. So this would be my correct factored form for that equation. Now, for each of these, when you don't have 3 terms on the inside of your parentheses, you can just stop for now because we're not going to talk about the patterns yet. So this right here in the inside of my parentheses is 2 terms of binomial, and this right here would be 4 terms, so polynomial of 4 terms. So we couldn't do any more factoring for now. Now we're going to talk about factoring trinomials. So factoring trinomials means you're going to have 3 terms. So before we start, let's talk about factoring the signs that we're going to need. When you're factoring trinomials, you're always going to end up with a binomial times a binomial if it indeed factors. Now, so I'm just setting up my parentheses, which is something that I always do for each of these problems. So you always are going to look for factors of the last term, which in this case is C, that add up to your middle term, which is B. So if both your signs are positive, that means that both your signs are going to be positive on the inside of your parentheses. Now, if you look at this next one, notice that our middle term is positive, but our last term is negative. If that is the case, that means you're going to have opposite signs because when you FOIL this out that we learned before, we would have our last term would be a positive times a negative is going to give you this negative C term. And that means since the middle term is a positive, your larger number or larger factor would want to be positive. So this one right here, since we have a plus on the outside, both our signs are going to be negative. And for this right here, if you have both negatives, that means they would have to be opposite signs as well. So notice real quickly that when you have a plus here and here, that your signs are going to be both positive. When it's going to be a plus here and a negative, your signs are negative. So notice that your signs for when that plus is on the last number, they're both positive. So a way that I remember that is plus for the third term is going to be same sign. And then if the other sign is negative, such as here and here, then notice that your signs are opposite for your set of parentheses for each binomial. So minus means opposite, so PSMO. So plus means that we're going to have the same signs if it's the third term, and minus means you're going to have opposite. So that's going to come in handy when we're doing some of our factoring. So let's go to the next page. Now on this next page, notice that the first thing we always want to do is factor out our greatest common factor. So I want to look for GCF first. So something that can go into all of these would be 2. So my greatest common factor is 2. So I'm going to factor that out first or divide it from each of these terms. So when I take it out of each of the terms, I would get x squared minus 4x plus 4. Now that I factor that out, notice on the inside of my parentheses I have 3 terms or a trinomial. When that happens, you want to see if you can factor it into 2 binomials with your parentheses so that 2 stays in front. And when I factor this, I have a set of parentheses here and here. So you always want factors of the last number that add up to the middle number. So I want factors of 4 that add to negative 4. So I'm going to write down factors of 4. So factors of 4 are easy. 1 and 4 and 2 and 2 are factors of 4. So for this one, since I have a plus sign here, that means that I know my signs are going to be the same. So since my sign in the middle is negative, that means my signs are going to be both negative, because a negative times a negative number would give you a positive last term, and a negative plus a negative would give you a negative middle term. So if I try to do both my terms negative here, like negative 1 and negative 4, would give you negative 5, so that doesn't add up to negative 4. If I did negative 2 minus 2, I get negative 4. So that means negative 2 and negative 2 are going to be my terms that go in here. And then since my first term is x squared, I would put an x here because I'm just breaking it up. And x times what would give you x squared? X times x. So then that means that this would be my answer. And we can even simplify this further. That would be 2 times x minus 2 squared is another way that we can write that equation right there. So let's go ahead and check our work. And how do you check your work? By boxing or foiling. So I'm going to go ahead and box this out just to check. So x minus 2, x minus 2, x times x gives me x squared. X times negative 2 is negative 2x, negative 2x, and negative 2 times negative 2 would be positive 4. So we get x squared. These are like terms, so minus 4x plus 4, and then don't forget we had that 2 in front originally because we factored that out. So 2 times x squared gives me 2x squared. 2 times negative 4x gives me negative 8x. 2 times 4 gives me plus 8. Notice this is the same as what I have up here, so that means that it checks out and that we factored correctly. So that's how you factor a trinomial. So let's do the next one. So number 5. When we look at this one, first things first, you want to always factor out your greatest common factor. That's always step 1. So when I take out my greatest common factor, you'll notice it's 5 xy goes into all those terms. So I'm going to take that out first, or divide it out and put it in front. So why don't you guys see if you can do this while I'm doing this? So when you do that, you should get x squared minus 3x minus 40. Now notice that we have 3 terms on the inside of our parentheses, which is a trinomial, so now we need to see if we can factor this further. So I know that 5xy stays here. I would set up my 2 sets of parentheses. I know x is going to go here and here. Since my signs are both negative and the negative numbers on the outside, I know they're going to be opposite, so a plus and the minus, because a positive times a negative is a negative, and that means that since our middle term is negative, we want our larger factor to be negative. So I need factors of 40. That add to negative 3. So if you are unsure about your factors of 40, this is when you could go to your calculator and you could go to your y equals and do 40 divided by x, and then go to your table and then find your factors of 40. So start at 1, 1 and 40, 2 and 20, 4 and 10, 5 and 8, and then notice we get to 8 and 5, so that means we could stop at 5 and 8. So I'm going to write those factors over here. 1 and 40, 2 and 20, 4 and 10, and 5 and 8. Now, once you get good at this, you don't really need to write all that's down. I'm just writing it down so you can see now. So the larger number has to be negative because my middle term is negative. So that means this is the larger number, this is the larger number, this is the larger number, and this one's the larger number. So 1 minus 40 does not give me negative 3. So that's not equal to negative 3, so it's not going to be that one. 2 minus 20 does not give me negative 3, so it can't be those terms. 4 minus 10 does not equal negative 3. 5 minus 8, however, though, does equal negative 3, and that's what we need. So that means that 5 is the positive number, and 8 would be the negative number. And so this right here would be my factored form. And of course, I could always check this by multiplying it out by foiling or boxing and seeing that it equals the original equation that I started off with. So let's go ahead and go to number 6. I'm going to erase this right here so that we can write. For number 6, now here, first things first, look for a greatest common factor. Now notice that there's nothing that goes into all 3 of these terms, so there's none. Now, since there's 3 terms, that means we want to see if we can factor this into 2 binomials. So both my signs are positive, so that means both these signs are going to be positive. This is an m squared, so m would go here and here. And notice this is an n squared, so that would mean we need an n here and here for our last term, because n times n would give us n squared. But notice the number is what we're concerned about. The number in front is 1, so that means we need factors of 1 that add up to 5. Now, if you look, can you have factors of 1 that add up to 5? No, so there are none. Since there are none, that means we can't factor this equation, and when you can't factor something, you actually call it a prime. So I'm just going to write that this does not factor. So then I would leave my answer as m squared plus 5mn plus n squared. So just because you have three terms doesn't necessarily mean that you can factor it. And again, things you can't factor are prime numbers, like 7 doesn't factor because 1 and 7 are things that multiply into it. 5 is a prime number, so these are prime factors. So this does not factor. So let's go ahead and go to number 7. So number 7 is kind of the same thing. We have the same variables except for I have a 10mn here and 9n squared there. So I have three terms. There's no greatest common factor. So I want to find factors of 9 that add up to 10. So factors of 9 that add to 10. So factors of 9. I know factors of 9 are 1 and 9, and then 3 and 3. So if I set up my two sets of parentheses here, both signs are positive, so both signs are going to be plus here. I have an m here and here, and since I have an n squared on the outside, I also need an n there and there. So since both of these are positive, 1 plus 9 is 10, so I know this is my answer, and I can stop there. 3 and 3 would give you 9, which is not 10. So I know that 1 and 9, and it doesn't matter which order you put these in. I could have put the 1 here and the 9 on this second binomial, or I can flip them around. It doesn't really matter. So this right here would be my solution. So let's check this one by boxing it out. So I'm going to erase these factors right here so I have some room. So when I check, I'm going to do the box method because I like that method. So m, and this would be plus n, and m plus 9n. M times m gives me m squared. M times n gives me m n. 9n times n gives me 9n m. And 9n times n gives me 9n squared. So these are like terms, even though I didn't write the variables in the same order. They are like. So I have m squared. 9nm plus mn gives me plus 10 mn. I usually write the variables in order of the alphabet. Plus 9n squared. Notice this checks out with this, so therefore I know that I factored correctly. And as I said before, I didn't have to write my factors in this order. If I wrote them instead like this, that would be okay as well. So either answer is correct, and I would accept either of those. So let's go to number 8. So for question number 8, it has three terms. Notice that there is no greatest common factor. So since there's no greatest common factor and there's three terms, I want to see if I can factor this by setting up my two sets of parentheses. I know p times p would give me my first term, which is p squared. And since my sign's negative here, that means these need to be opposite. Since my middle term here is negative, that means my larger number is going to be negative. So factors of 30 that add up to negative 7. So let's use our calculator to help us again. So I'm going to do 30 over x. Go to my table. And factors of 30 that add up to negative 7. And so we said the larger number has to be negative, so I'm just going to do this on my calculator this time. So this would be negative right here. So 1 minus 30 does not equal negative 7. 2 minus 15 is also not equal to negative 7. 3 minus 10, this one right here does, so 3 and 10 are my factors of 30, because 3 times 10 is 30, and 3 minus 10 gives me negative 7. So factors of 30 that add up to negative 7. So when I go back to my paper here, that means that my larger number is negative, the smaller number is positive. So p plus 3, and then p minus 10. And so that would be my answer. And of course, I could check it by foiling this out or by boxing it out. Now, let's go ahead and look at number 9. For number 9, I have 4x squared minus 12x plus 9. So for this problem, there is no greatest common factor. So since there's no greatest common factor, I have 3 terms, but however, notice this first term right here is not 1. When you have no greatest common factor and your first term in front of your x squared quadratic term is not 1, then we're going to use slide and divide method. And you're saying, what is the slide and divide method? So let's go back to the other side of our paper. If we go back to the other side of our paper, slide and divide. Now, I use this mnemonic device, which is Swedish fish don't really swim. So if you know what those little candies are, those candies are the Swedish fish, and they don't really swim because they're candy, so they're not actual real fish. So we use this mnemonic device and we take the first letter for each word. So S, F, D, R, S. So S stands for slide, F stands for factor, D divide, R reduce, S swing. So slide, the number in front, and multiply by the last number. That's slide. F stands for factor, so you're going to factor the new equation. D stands for divide, so divide the factors by the number split with in the beginning. R, reduce the fractions. And S, swing fractions denominator in front of the variable. So these are the steps that we are going to follow when we're factoring trinomials with no greatest common factor and the leading coefficient is not 1. Well, I guess it doesn't necessarily have to be the leading coefficient, so we'll just leave it like this for now. So let's go back to that problem. Okay, so now going back to this problem, so we're going to follow those steps. So I'm going to erase this right here so I have some room to write. Now, I'm going to write the steps down. So Swedish fish don't really swim. S stands for slide the number in front to the number and multiply it by the number in back. So 4 times 9 is 36. And so we're going to write our new equation down. So x squared minus 12x plus 36. Now this should look familiar. We just factored problems like this, so you should be able to factor this on your own. So try to see if you can do that. Oops. So since my last sign's plus, I know both my signs have to be negative to get a negative middle term. So I need factors of 36 that add up to negative 12. So let's go here. So factors of 36 that add up to negative 12. So factors of 36, 1 and 36. So both of our terms are going to be negative, so that's not going to work. 2 and 18, not going to work. 3 and 12, not going to work. But if I have 4 and 9, does that work? Nope, because that's going to give me negative 13. 5 and 7.2 we can't use, but 6 and 6, 6 negative and 6 negative is going to give me negative 12, so that's going to be my factors. So negative 6 and -6. So now that I have my factors, divide means divide by the number we slid by. So we slid with 4, so I divide each of these numbers by that number there. R stands for reduce those fractions that we just wrote. So x minus 3 over 2 and x minus 3 over 2. And S stands for, if you're left with something in your denominator, like the 2's, you're going to swing those numbers in front and put them in front of the variable. So this would be 2x minus 3 and 2x minus 3. And this right here would be my factored form. Since there's two of them and they're the same, just like if I had x times x, I could write x squared. So I can write here 2x minus 3 all squared would be the same thing, and I would probably write that one because it's the more correct answer. Now let's just check our work and then we'll be done for today. So I'm going to check by multiplying this out. FOIL or box would work, doesn't matter which method you use. So 2x minus 3, 2x minus 3. So 2x times 2x is 4x squared, minus 6x minus 6x. And then this would be 9. I have like terms right here. So 4x squared minus 12x plus 9. This is the same thing as what we started off with, so it's easy and it checked out. So these problems are nice because it's very easy to check your answers by multiplying it out. So if you have time, I suggest doing that because it's a good way to just practice foiling and boxing and also with your factoring. So for these, we're going to finish these last questions here. So we'll do 10, 11, and 12 in class. But make sure you go through and look at everything we did in this video. And just to go back to the beginning, so remember that the first thing you always want to do is factor out the greatest common factor. If it's a binomial, eventually we'll look for patterns, which we're not going to do yet. So you don't have to worry about that. So the patterns are difference of cubes, difference of squares, and the sum of cubes. For right now, we have, if it's just a binomial, just factor out the greatest common factor if there is one. Trinomial terms, which means 3, we're going to factor. If the leading coefficient is 1, then find the factors of the last term that add up to the middle term. If the leading coefficient is not 1, then factor using the slide and divide method. So if there's something that you missed, make sure to go back and look at that and have all this ready for class.